humans are an energy-hungry species. Our homes, cars, and industries, our cities and airplanes, everything we're about needs fuel or some energy alternative. We power our world by driving energy from temperatures that rival the sun down to those of cold outer space. Miguel de Cervantes once spoke of the fire that warms cold, the cold that moderates heat, the general coin that purchases all things. That contradiction of fire and ice touches every kilowatt we use. We look for the day when renewable energy sources will harness heat and cold to provide all the energy we need. But for now, we have to rely on a mix of energy sources. Wood was the world's primary fuel for millennia. Coal began displacing it in the 13th century. From then, through much of the 19th century, coal was the Western world's dominant energy source. Then we discovered the extent of subterranean oil, and our energy economy would be dominated by oil through the next century. And for good reason. It's abundant and affordable. But today things are shifting once again. Now natural gas has become abundant and affordable. Production is growing. Natural gas yields 27% less CO2 than oil, 49% less than coal. Unburned natural gas is itself a greenhouse gas, so we're taking increasing care to fully contain it before we use it. But once burned, it yields almost no pollutants, only the same carbon dioxide and water that we exhale all the time. There's more. Our means for finding, extracting, and producing natural gas keep improving. Now we can even extract gas from shale. Who saw that coming? But natural gas takes up a lot of space, and that brings us to LNG, liquefied natural gas. The great British chemist Michael Faraday showed that liquefaction was possible. He turned a number of gases into liquids in 1823, and oil gas vapor was among them. German engineer Carl von Linde pioneered the liquefaction of air in the late 19th century. The U.S. created the first large natural gas liquefaction plant during World War I. Why? It was to extract residual helium from natural gas for dirigibles. So why should we liquefy natural gas? We're not in the dirigible business. The reason is space. We can put 600 times as much LNG into the same space as gas. That makes it safer and cheaper to store and transport. The mid-1940s to the 60s found power companies liquefying natural gas during periods of low demand, then regasifying it to meet peak demand. But pipelines were, and still are, the first choice for moving natural gas until, say, we need to cross an ocean. LNG's real advantage would be connecting producers and users on other sides of the world. That would bring the benefits of natural gas to more users. It would spur economic growth in both supply and demand regions. But we had no good way to ship LNG across oceans. Enter Chetty Slepcevich, a young chemical engineer and professor at the University of Oklahoma. The team he led converted a World War II Liberty ship into the first commercial LNG tanker. It was the Methane Pioneer. It reached Great Britain from Lake Charles, Louisiana in 1959, and the modern LNG era was underway. Liquefaction processes keep evolving. Increasingly large and efficient turbines, compressors, and heat exchangers turn gas to liquid. And the ships that carry LNG, well, Chetty Slepcevich would be amazed. Natural gas is now burgeoned into a fuel of choice. Its use is served by a dazzling array of new technologies. Now we offer full access to its near 2,000 degrees Celsius flame temperature by liquefying it all the way down to 162 degrees below zero. Technology teems with wondrous contradictions, does it not?